Hi, my name is Fernando Araujo. I'm going to talk about the topic equivalence of the second order dynamics of mass spring damper mechanical systems and the RLC electrical circuits. Now, what is a second order system? The second order system is the lowest order system capable of an oscillatory response to a step input. Typical examples are the spring mass damper system and the electronic RLC circuit. The time domain function is 1 over omega squared y double dot plus 2 times 0 over omega times y dot plus y equal to x. Now the Laplace domain transfer function is gs that is equal to ys over us that is equal to omega squared over s squared plus 2 times 0 times omega times s plus omega squared. We get ys is the output and us is the input. Now, I'm going to explain the simplest example of a mass spring damper system. First, in this example, we get our free body diagram. From the free body diagram, we easily obtain the following equation of motion by the sum of the forces acting in the mass. We have two formulas to write the equation. In my opinion, I prefer the second one because it's more easier to understand, more easier to write, and more easier to use. So the equation is f of t is equal to mx double dot plus cx dot plus kx. Now, taking the Laplace transform on both sides, we get that the fs is equal to ms squared xs plus cs xs plus chi xs. Now, clearing xs, we get that we have xs over fs that is equal to k over ms squared plus cs plus k. Why is a k in the numerator? Because it's our input, so we put it in the numerator. Now, we have to leave s squared alone because it's the typical equation of the Laplace form. We have to leave s squared alone. So xs over fs now it's equal to k over m over s squared plus c over m s plus k over m. Now with the last formula, leaving s squared alone, we can get the angular frequency and the damping ratio. With the omega n, with the angular frequency, it's always the square root of the numerator of the Laplace transform. Or if you want to call in different way, it's omega n squared equal to the numerator of the Laplace transform. So omega n is equal to the square root of k over m. Now this is 0, but the real equation is 0 to 0 omega n equal c over m. But I already cleared the formula from 0. Now this 0 can be simplified more because omega n is equal of the square root of km, so we can simplify more the expression. And the expression that we get is 0, it's equal to c over 2 square root of k times m. Now, we do exactly the same with the RLC circuit. It's the simplest circuit, the simplest example. And the resistor, the capacitor, and inductor in the voltage are UR Ri, UL is equal to L times the I over the T, and the Vt is equal to 1 over C times the integral of I dt from T0 to T. Now, applying the Kirchhoff voltage law, we get the Li double dot plus Ri plus Ci dot times I equal to Vi. Now, I want to explain that this I, it's not like this I. This I, it's like in the previous example, it's like we get chi x. This is Ri, and this Ci is Ci dot. But unfortunately, the equation editor can't understand that. So this is Ri like Ix in the previous example, and this is Ci dot like in the previous example Cx dot. So taking the Laplace transform on both sides, we get Ls plus R plus 1 over Cs times Is equal to Bs. Now, I prefer don't have divisions in the equation, so I multiply times Cs. So I get Bs equal to Cls squared plus Crs plus 1 times Is. Now, clearing Is, we get Is over Bs is equal to 1 over Cls squared plus Crs plus 1. Now, as I said in the previous example, we need to leave s squared alone. So leaving s squared alone, we get xs over fx equal to 1 over cl over s squared times rls plus 1 over cl. Now, with the last formula, we also can get the omega n and 0. And as I said in the previous example, the omega n is omega n squared equal to the numerator of the Laplace transform. So omega n is the square root of 1 over Cl. And 0, it's the original equation, it's 2 omega n 0 equal R over L, but I already cleared it, as I say in the last example, to be easier. So this 0 can be simplified a lot more. So 0, it's going to be 0 equal to R over 2 times square root of LC. And that's all. Thanks for your attention.